Hello, this is Robin speaking, and you are very special. Now, that might sound a bit cliche, but I mean it in a very literal sense, because you probably have no idea of how extremely unlikely your very existence is. So, I wanted to make this series of videos trying to just give you a small, tiny little bit of a taste of how unlikely and special is that we are all here. Everything around us is here because there have been millions and millions of years, billions even, many things happening, many unlikely events, some that would defy all predictions that still happened. And that led us to be where we are. And I just want people to realize how really special everything that's around them is, so that they can appreciate life more and that they can experience it. So this is the first episode in this series. This will be about the beginning of the universe. I'll be doing this in chronological order until we reach your personal existence. So without further ado, welcome to Victorville. Now let's go back, all the way back. To a time where there wasn't even time, or space for that matter, or matter for that matter. Basically, we don't know a lot about that time before the Big Bang, because our models of physics right now don't work under those conditions. But what we assume happened is that there was this small, little, infinitely dense point full of energy that suddenly started expanding at an impressive rate. Just a few seconds it became huge, and it had all the ingredients to make matter and energy in it. So I can't tell you how unlikely that is to happen because our models don't work in that. But then we reach this point right after the Big Bang, when there's this soup that is millions and millions of degrees, so it's really hot. Matter starts to form, and antimatter and dark matter and energy and dark energy and all kinds of stuff happen there. And that's a very important part of our history, because that's when the concentration of the different parts started to exist. Now there's this thing called the cosmological constant that basically tells you what's the energy density in the universe. If that density is close to zero, it means that the universe will stay stable. If it's positive, it will start accelerating more and more. And if it's negative, it will start compressing. Now, the universe in which we live in, it's fairly flat, which means that this constant is almost zero. It's slightly positive, it's not completely zero, which means that the universe is expanding. Slowly, but it's going faster and faster every time. But it's still pretty slow because it's really close to zero. Any other number for that constant that could have happened, and that includes infinitely many numbers in any direction, negative and positive, the universe wouldn't exist, not as we know it. If the constant was negative, it would have collapsed right after the Big Bang. A few seconds later, maybe less, and there would be nothing. If it was positive, more positive than it is right now, it would have just expanded too quickly, so the matter would have never found itself, so there would be no molecules, no atoms even, so there would be no planets, no galaxies, no nothing. Just basically empty space with particles flying around it. Now another thing that we're very lucky to have are particles. Things like electrons and quarks and all kinds of elemental particles, fundamental particles that just happen to be the right sizes and the right energies to interact with each other in such a way that they can form atoms and build things with them. Because one could possibly conceive an infinite number of universes that contain matter, but that matter works in a way that molecules or particles even can't bind to each other, so they can form any more complex things, or that there's matter, but on a different form that doesn't even work like our matter in any way that we can think of. So yeah, that reduces the possibilities for universes to exist dramatically. The next thing that we should be very thankful for is gravity. You know, gravity is often neglected because we just take it for granted, but gravity does much more than just keeping us grounded to the floor. It also helps galaxies stay in shape, form even. It helps planet be a planet and not just flying dusts around everywhere. And one could conceive many universes in which gravity just doesn't work like the way it does here. Maybe there are some universes, possible universes, where gravity is very strong, so each particle can attract all the particles around it, and everything collapses into black holes because of the extreme density that would cause. Or maybe gravity would be too weak and nothing could form because things wouldn't stick together. So gravity is also something really, really unlikely that we have. It's great. Now we have all the necessary ingredients. Now we have all the basic ingredients for the universe, most of the universe as we know it. Basically, with gravity and particles and a nice cosmological constant, we can start building galaxies. But first we have to build stars. And stars are just clusters of particles that get very close together, and because of all the pressure that they form, they start emitting energy to the universe in the form of light. This is a very gross oversimplification, but I think it's enough for this video. Basically, with that, we can start thinking about more complicated stuff, because the first stars were made up of only hydrogen and helium. But then, due to these extreme pressures, atoms started joining with each other and causing fusion and creating heavier and heavier elements. And once these primal stars started to explode in supernovas, because it's the end of their lives, heavier elements started to go all throughout the universe. And that allowed for the creation of planets, which are not made of only those. For example, Earth is made a lot of things, carbon and iron and everything that we know today, and that came from the stars exploding in the beginnings of time. And this also brings us to a very important part. Remember back then when I told you there was a soup, a very, very hot soup with all the ingredients? Well, in that time, the universe, all the visible universe, was compressed in a few centimeters, maybe less. And basically, the density of matter within that little soup determined the density of matter in the whole universe now. So as it expanded, those clusters of matter that held together are what gave rise to our galaxies today. So if they had been scattered all around, there would be no galaxies, because everything would be scattered all around. So we're very lucky that we have those little galaxies together, and that's where the supernovae, when they exploded, they sent heavier elements to all these clusters of gravity caused by the matter there. That helped create more stars and the planets, including planet Earth. Now I think that's it for this video. In the next video I'll cover how we go from this mess of particles of space to a planet with life. So I hope you're excited about that. I know I am. I've been wanting to do this for a long time. So yeah, but that's it for today. I don't want this to be too long. I just want to say hi to my friend Majo, who left a very nice comment on my last video, and Raul, Jordi, if you make a video someday for your challenge, I want you to tell me something that's going on in your life right now, because this might be the last video that I'm making from Mexico in a while. I don't know how long. It could be 3 days, it could be 4 months, it could be over a year. I'm leaving next Wednesday to my next location. You'll see that soon. So I don't know if I'll be able to make another video in time. So I'll see you when I see you.